This is part of our video series on human-centered evaluations for NLP explanations. Check out the link for more resources. You're currently here.
Thanks, Vera, for the overview. I'll now give a quick intro to experimental design before turning it back over to Vera to illustrate these concepts with specific explanation use cases. In this crash course on experimental design, I will detail how to choose your research method and design your experimental task, including how to operationalize your measures and design your task procedure. There are many different experimental methods to choose from, including interviews, lab experiments, and surveys, and the right method depends on where you are in the research process and the questions you're trying to answer. So in system design, research can be either formative or summative. Formative or exploratory research is used to understand user needs, evaluate, and refine ideas. Formative research is appropriate for early stage research, looking to understand things like, for which model outputs do users need explanation, or generally, what explanation qualities do users desire? Here you might use interviews or surveys to gather open-ended insights. Summative or empirical research is used to validate systems and test hypotheses. It's appropriate for later stage research to answer questions such as, does explanation improve performance, or which explanation style improves understanding? Here you might use a controlled lab experiment where you compare explanation alternatives, or a field study where you observe people using your system in an actual environment. We also differentiate between quantitative and qualitative methods. Quantitative methods help us to understand the what, such as how quickly users perform a task or how frequently users interact with an explanation. Alternatively, qualitative methods answer the why, like why was a particular explanation type preferred, or why a model output was frustrating. Our focus for this tutorial is on controlled experiments for summative research, where we want to test and evaluate system explanations against our hypotheses. We suggest quantitative approaches supplementing with qualitative methods, or with mixed methods approaches. So at a very high level, in a controlled experiment, we start with a testable hypothesis, perhaps that an explanation will improve performance for a task compared to no explanation. To test this hypothesis, we split our users into groups. From there, we manipulate independent variables, such as whether or not a user receives an explanation. And then we observe dependent variables, such as performance. Finally, we run statistical tests to compare the two groups, asking, did the group who received explanation perform significantly better? And then we accept or reject our hypothesis. So let's walk through how you design a controlled experiment. Particularly, we suggest application-grounded experiments centered on an explanation use case. We'll talk through high-level considerations for experiment design now, and Vera will discuss some specific examples of application-grounded experiments in the next part of the tutorial. So first, you'll revisit your goals. For your explanation use case, what are users' objectives? Why do users need explanations for those objectives? Is it so they can provide feedback to improve the model, or to make better decisions aided by the AI for a task? Or perhaps it's to assess fairness or bias. So from our example before, our goal is to improve users' decision-making performance. Next, you'll articulate your research questions and hypotheses. So think about how your explanations will affect your goals and why explanations can or can't achieve your goals. So from our example, our research question is how explanations affect decision-making performance, hypothesizing a positive effect. So given these research questions and hypotheses, we can design more details of the experimental tasks. Importantly, I want to point out that each of these steps can inform the others. For example, your choice of measures can inform your treatments or your procedure. Experimental design is very much an iterative process, not step by step. But with that said, let's walk through each of these step by step. So first, consider the different treatments, or what are your experimental factors or conditions that you're comparing. You might do a simple comparison of yes versus no explanation, or you might do a two-factorial design where you compare explanation and model performance. and your design tells you how many different groups you'll need to compare. Next, you'll choose your evaluation constructs. For application-grounded evaluation, it's important to always measure use case-specific outcomes. We'll share more examples later in the tutorial. Additionally, it's often helpful to measure model understanding. This can help you to know whether explanations had an effect on user mental models. You should also consider other user effects of explanations that they might have. So these can be both positive and negative, such as on users' cognitive load, or how long it takes them to process the explanation and perform the task, and on their perception of the AI model. Given your evaluation constructs, you need to operationalize them with specific measurements. So a construct can have many different ways to operationalize its measurement. At the basic level, we can differentiate between objective and subjective. So taking understanding as an example, we can measure objectively by testing users' mental model, such as asking users to simulate what a model will output given a particular input, or which features were most important for a decision. We can also measure subjectively to get at the user's perceived understanding by asking them to self-report with rating scales, such as their agreement with the phrase, "I understand how the AI works." And going back to our experimental design, we next need to characterize our participants. They should reflect the audience for the target use case. So you'll want to consider their domain and dataset expertise and their machine learning or AI expertise. In both cases, you might want only non-experts, experts, or a mix of expertise. You should ensure an even distribution from different ages, genders, and other groups. And how many participants you'll need depends on the task design. You need to ensure that you have enough participants to give statistical power to test your hypothesis. So in general, controlled experiments need lots of participants. Going back to our experimental design, we next need to characterize our participants. They should reflect the audience for the target use case. You'll want to consider their domain and dataset expertise and their machine learning or AI expertise. In both cases, you might want only non-experts, experts, or a mix of expertise. You should also ensure an even distribution from different ages, genders, and other groups. How many participants you'll need depends on the task design. You need to ensure you have enough participants to give statistical power to test your hypothesis. In general, controlled experiments need lots of participants. Finally, you can develop your procedure, or how participants will perform the task. First, determine whether your experiment will be designed as within subjects or between subjects, meaning, will participants see only one treatment or multiple? Within subjects is useful for asking about users' preferences, such as whether they preferred having or not having an explanation. However, between subjects is better for overcoming ordering or training effects. So for example, in a within subjects design, you can imagine that participants who receive explanations in the first half of a study will gain a better understanding of the system, which would then affect their performance in the second half of the study, even without explanations. Between subjects overcomes these potential confounds, but requires more participants. You should also consider other phases your participants might need. For example, you'll likely need to include a tutorial to explain how the task or system works. This can include specific examples of what participants can expect to see during the task. You'll also determine how many instances or tasks participants will do, or how long they'll spend with the task system. If you'll have participants interact with the task system over multiple instances, you need to consider their order. Typically, you'll want to randomize instances, as using the same order all the time can lead to learning effects, where participants do better on later instances than earlier ones. And all of this comes together to make up your study plan. So now Vera will go through some specific examples of evaluations before we come back to some evaluation challenges and tips for success.
This video isn't the end. You're currently here. If you're lost, click on the link below for source code, slides, and other resources.